Hello and welcome to this video tutorial on higher order array methods in JavaScript. First of all, what is a higher order array method and how does it differ from a normal array method? So what defines a higher order array method is that it accepts a custom function as an argument. And we are going to be looking at four very commonly used higher order array methods in this video. First of all, .map, then .filter, then sort, and finally reduce. And these array methods, they're very, very useful, not only in vanilla JavaScript, but also if you are using an advanced web framework like React for not only parsing data from one component to another. So you might want to filter the data that's being passed with array.filter, but also for templating. And in that case, map is very useful indeed. Now, these four array methods, they all have three features in common. The first is that the function accepted as an argument we define ourselves. It's a custom function, and this makes higher order array methods very flexible. If you think about a regular array method like .push, which pushes an element to the end of an array, or .pop, which removes an element from the end of an array, they have a fixed functionality. But with a higher order array method, we actually get to define how the higher order array method works on the array. So, for example, sort of within the confines of what the method actually does. So array.filter, for example, we can define exactly how that filtering is going to occur, on what basis it's going to occur. So it's not a fixed functionality, but we have a lot of control over it. The second common feature of these four array methods is that the custom function that we pass in as an argument, it must always have a return value. So that could be true or false, or it could be a numeric value. And what it expects depends upon the array method itself, but you must always be careful to supply a return value when you are writing the custom function. And finally, the original array is left untouched. So each of these methods produces a new array, and you don't have to worry about your original array being sort of distorted by the application of the array method. It's going to produce a new data object, and if this is a data object that you want to keep in its original state, well, that's fine, because none of these array methods are actually going to change it. So that's a very useful feature of higher array methods as well. So let's start by looking at the map method. Now, the map method, like all of the higher order array methods we're going to be looking at, it accepts a custom function. So you can write this as an arrow function. They are always anonymous, or you can write a regular anonymous function there. It doesn't matter, both will do the same job. So I could write it this way, and then the code statement inside the brackets here, or I could shorten this, and this is my preferred way, to an arrow function here. And what we have available to us here in map is each element in the array. So I'm going to call that number. Now what map does is it applies our custom function to each element in the array and produces a new number or value. So we can, so it's great for making an identical change to each element in the array. So for example, let's say we wanted to increase the value of each number by 1. So this would, in the first run of the map method, this function would be applied to 1 at the beginning. So this would take number plus 1, this would be 2. And then in the second run, it would apply this custom function we've written to the second element, and so on. So that's how map proceeds. And as I mentioned earlier, we have to supply a return value, otherwise it's not going to work. So it expects this value to be returned, and this is what it's going to use to construct the new array. So to access that new array, we could either wrap this in an entire console log, but what I'm going to do is put this in a new array. So I'm going to call this array map, and then console log that. So now we should see the new array with 1 added to each of the values. So let's head over to the console, and you can see here it's now 2, 4, 7, and the array began with 1, 3, 6. So you see that we've added 1 to the array. Now this isn't so useful. There might be some contexts where you want to do this if these are ID numbers, but quite often what you'll want to use map for is for templating. So it's very, very useful for that. So how do you do templating with map? Well, you would, for example, you can do it with a template literal. So I'm going to open one of these, and it's going to return this. Actually, what I'm going to do is I'm going to save this in a variable called template, and then I'm going to write my template. So I want to keep the example nice and simple, just for the purpose of this tutorial, but of course your real world usage will be much more complex. So we're going to, what we can do with a template literal is interpolate a value, and what I want to do is each time I want the number to be displayed in this article. So I'm basically writing HTML here with a dynamic value interpolated, and then what I want to do is I want to return the template each time, and then that's going to create an array with this template that I could then write to the DOM using the inner HTML method. And you can see here now that we've got our article with 1 for the first article, and then 3, 6. So you can see each time it's being printed out, and we've got that saved now as an array. And we've got all these spaces here, so we might want to actually remove those entirely. So let's have a look now. And you can see that now we've got each of these without any spaces. So that's how map works. Very good for making a change, an identical change to each element, and also for templating. So I'm going to now comment that out, and we'll move on to filter. So the way that filter works, as the name suggests, is it filters down our original array and produces a new array which will be shorter if the custom condition is sometimes false. So to show you what I mean, first of all, I'll include the custom function, and it has to have a return value. And then we have available to us, much like map, we have available to us each element in the array, and this is going to run as many times as the length of the array. And for each array element, we are going to be returning a true or a false value. Now we could hard code it like this, and the array would be, it would keep all elements and produce those in a new array. False, we would end up with an empty array, but that's not the way we usually use filter. We want to create some condition that's going to filter the array in some way that's useful to us. So for example, we might say number is less than 5, and this would produce a new array where only the values less than 5 are included. So to view that, we need to actually save the result in a variable. So I'll do that now and then log it to the console, and then hopefully we should have our new array available to us. Head over to the console, and we have 1, 3, 4, 2, 3, 0. So all of our values are now under 5. So that's very useful, especially for passing data around. Let's say you have some blog posts and you only want to include some that are, for example, past a certain date, or only subset of blogs on some basis, then filter is the array method for you. So the way that sort works is this is going to sort our array in a way that we specify. It's a little bit more work than map and filter because we need to do a little bit more work with the custom function. So unlike map and filter, we have two parameters available to us. We have A and B, and A is going to be our index value that we can reference in the function, and B is the value it is being compared to for a particular run of the custom function within sort. So we need a return value, and we also need to make a comparison between A and B. If the comparison turns out to be positive, then A is going to be pushed after B in the array. If the comparison is negative, then A is going to remain before B in the array. So let's do A minus B as a comparison. That's going to produce a positive or negative value. And then we're going to, down here, in fact, what I'm going to do is I'm going to shorten this array, and then we can do this by hand, look at how sort works under the hood, and hopefully that should help you better understand the sort method. So in the first run, our index value is going to be A. So A would take on the value of 1, and the comparison value is going to be 3 in the first run. And then what sort does is it takes the same index value and compares it to the next element in the array. If we had more elements like we do up here, then these would continue, it would continue comparing these. And then after it's finished, it then takes the next element in the array and then compares these to all the other values. But I don't want to go through all of that. I'd rather work with this smaller example for the sake of this tutorial. So let's do the comparisons by hand so you can see exactly what's going on. So first of all, it's going to take on the value of 1 minus 3. The second comparison is going to be 3 minus 6, and then our index value is then going to be 3, and that's going to be, that one's going to be 1 minus 6, and then our index value changes to 3, and then it's 3 minus 6. Okay, so we'll just work out what the outcome value for each is. So first of all, we would have 1 minus 3, minus 2, 1 minus 6, that's minus 5, and then 3 minus 6 is minus 3. So what's this going to do to the order? So we're saying index value of 1 minus 3, so the outcome is negative minus 2. So 1 is going to stay before 3. Is 1 going to stay before 6? Yes, because it's a negative value. So 1 is staying before 3 and before 6 like it is in the array. And then 3 is our new index value. Is that going to stay before 6? Yes, it is, because there's also a negative value there. So our array, the new array we produce by applying sort, is actually going to be exactly the same as the original array in this comparison. So I'll just save that in a variable, and we'll log that to the console so you can see that. So it has been applied, it's just we can't see we won't be able to see any difference between the old array and the new one. It's just reproducing the original array effectively. So let's change this comparison now. So we do see a difference in the array, so B minus A. So in this case, A is still our index value, okay, but this time we're taking the value it's being compared to, and then we're taking away the index value. So we're taking 1 away from 3, we're taking 1 away from 6, we're taking then 3 away from 3 away from 6 there, and this should be taking 1 away from 6 there. Okay, so what are the values of these? 3 minus 1 is 2, so we're just reversing these. 6 minus 1 is 5. 6 minus 3 is 3. So these are all positive. So what is this going to do to our array? Our index value A is going to be, first of all, 1. Should it appear after 3? Yes, it should. Should it appear after 6? Yes, it should, because they're positive. So 1 is going to go to the end of the array, and then should 3 appear after 6, and that's positive, so that's going to appear after 6. So what's actually going to happen is we're going to reverse the array. Effectively here is going to be the outcome. So this should now work, hopefully. Okay, so that's about all there is to know for sort. Okay, so finally in this tutorial, what does reduce do? So reduce takes takes an array, it works through the array and reduces it to a single value. So this could be, for example, the sum of all of the elements in the array taken together, and we can calculate the average quite easily from that as well. So that's the example I'm going to show you here, but you could do whatever you want to in the array to produce a single statistic that may be useful for you. So here's the array. We apply the reduce method, again, custom function. The difference here is we have two parameters, and the first one is what we call the accumulator. We can reference that in the custom function, and the second one is current value. So much like map and filter, the reduce method goes through the array one element at a time, and that value is in each run current value. The accumulator starts at 0 and is the return value for each run. Okay, so this is why it's called an accumulator, because it changes with each run, accumulates whatever value is being sort of returned. So our return value, in this case, what we want to do is we want to add all of the values up together to see what their total is. So for this, we would say we want the value of the accumulator, which in the first run is 0. We want to add current value. Okay, and so the accumulator in the first run is 0. It's going to be plus 1. That's what we're going to return in the first run. So then the accumulator in the second run is going to be 1. Then we're going to add 3 to it. And then in the third run, it's going to be 4. And then we're going to add 6 to it, and so on. Then eventually we're going to reach the end, and what the reduce method produces is the value of the accumulator at the end of its working through the array. So I will just console log the outcome of this. So array reduce array reduce, and now we should be down to a single statistic, so 58. So altogether this accumulates to 58. And if we want to get an average, this is a nice way of doing it because we've added them all together. Now what we can do is just divide this by the length of the original array, divide by array dot length. Okay, and that's going to produce statistics. So that's going to be average, array average, and yeah, log that to the console. So I'm doing this outside the reduce application of the reduce method itself, but that is fine. Okay, so the average value of this array is 4.833 reoccurring. Okay, so that is it for the higher order array methods that I wanted to go through in this video: map, filter, sort, and reduce. Now, we've used a very simple example throughout this tutorial. We've used this array of numbers. Of course, in reality, you're probably going to be working with a more complex array object, and the custom function you want to use may be more complex than those we have written here, but I think it's really important to understand the logic behind each method and what they're actually doing, rather than working with complex data. That just makes understanding more difficult. So these are really great to use in your projects in vanilla JavaScript, also very good for web frameworks where you're templating and passing data around. I hope you feel confident now that you will be able to use some of these array methods at appropriate points in your own project. Okay, so that is it. If you did like this content, don't forget to subscribe to the channel Open JavaScript on YouTube.